This building was built in the 1960s and inherited by A&M in the 1970s. Cotton program, forage program. I took it in the forage program in 2009. Texas did not enable a new building or center for hemp, so this now houses perennial grass breeding and industrial hemp, so it's a dual use facility. We tried to optimize it for hemp production starting in 2020. So it's a lot of repurposed rooms. Texas made its own law, but it's modeled on the USDA, the Farm Bill. Any plant that has less than 0.3% THC in it is legal to grow in Texas. So for CBD, or for grain, or for fiber, they're all legal to grow in Texas. The state law for growers, they can get a grower's permit and a commercial permit, but they can't do any breeding or research. The state law only approved research for universities. Okay. And the only research permits that were given in 2020 were for Texas A&M and Texas Tech. There are a few other universities now doing research as well, but the vision was to have all research on hemp done by the universities. Yeah, it's been great. We have highly motivated students, highly passionate students. They're looking for new crops. You know, farming is thought of as boring and ancient and not all that innovative. With hemp, everything we're doing is innovative. It's been not researched for 80 years in the United States. So a lot of highly compassionate students and motivated students. Some traditional farmers want it for fiber and grain. Some medicinal want to use it for CBD. Others want to work it to make renewable bioproducts or building materials. So they come from different departments. We have engineers, we have horticulture, we have soil and crop, plant pathology, almost all within the College of Ag, but a diverse pool of kids.
So I originally started out at A&M Kingsville my freshman year, and then I ended up applying for a transfer to Texas A&M College Station, and I got the great opportunity to work an internship with Texas A&M AgriLife in Corpus Christi. Well, during that year, they were doing a field trial across Texas, testing 40 different cultivars, and within that time, that summer, Dr. Jessup actually came down to Corpus, and I got to meet him in person, and I just found out that I got accepted for my transfer to Texas A&M, and I asked if there was any opportunities. Well, he said absolutely. He was looking into hiring more students to come aboard, and so I helped Dr. Jessup basically build this program with the other students as well from a very early start. So my main project is the hemp conversion program, and I basically reach out to breeders and growers all around the world within a 30 degrees north latitude and a 30 degrees south latitude if they'd like to make a donation of their pollen to our germplasm bank. And basically that is the development of southern coastal adapted plants that we're aiming for that are going to be compliant hemp varieties under the 0.3% THC range. And so in 2018, at the federal farm bill, when hemp was federally legalized and could be grown all over the United States of America, USDA released over 100 different varieties that were approved to be grown. Well, there's only really 8 cultivars that are commercially available that everyone's growing, so everyone's growing the same varieties, such as cherry wine, USO 31, and a bunch of different others in that 8. And there's very limited amounts of varieties that are for grain, fiber, and cannabinoid types, and so USDA ARS actually funded this program for $200,000 to increase the diversity amongst the hemp cultivars that are approved right now. And we're aimed to release over 100 different cultivars by 2025. So a cultivar is a finished and released line of whatever crop you're growing. So right now, these would not be considered cultivars, they're considered varieties, and so each variety is its own family, and that family differs from each different tray that's here. Each tray is its own family of different genetics, and basically, once we have gone from the initial parent cross, we take our varieties that are compliant under the 0.3%, we take the pollen and mix it with our varieties. We then take the seed from that original parent cross, and those will be considered F1s, and in those F1s we will take Ezekiel Soto's methods of self-pollinating, inducing Monishi within the plant and making it self-pollinate itself to get to the F2 generation. Because in the F2 generation, it splits into the most diverse range that you can choose from, where we're going to find that compliance under 0.3% THC. We'll then increase seed on that F2 generation, and then we will make another cross with another compliant strain to get a new F1 that will be completely different from anything else that is approved to be grown by USDA, and will be completely uniform.
So during my senior year at Texas A&M, it was the first year for the hemp production class. It was offered in our department. They were showing us, it was an interesting class. It was whenever they were first starting getting the rules and regulations for hemp. And that's when they were discussing about there are opportunities at Texas A&M to research hemp. So yeah, I took that my senior year. The following year, I emailed Dr. Jessup to see if he had a position available in his lab for a graduate student. And I was very fortunate enough for him to have a position. And that's how I got in. My project is the induction of monoecious in Cannabis sativa. It is a dioecious variety, meaning that there are both male and female plants. Just like in humans, we have boys and girls. In cannabis, we have boys and girls. Majority of the crop in cannabis is female because that's where you produce your cannabinoids, you get the bud, you get the seeds, and majority of the fiber. In order to breed, you do need male and female plants. The important inbred lines is have a plant to pollinate itself, which is kind of hard if you have separated sexes on the plants. So with my project, I'm able to induce Monishi inside the plant, meaning that we have both male and female plants or flowers on the same plant and able to pollinate itself and produce seeds. The main goal of inbred lines is uniformity. The biggest trait we're looking for is heat and drought tolerance in our varieties. So each of these plants will produce its own individual line, hopefully that are heat and drought tolerant, and whether it's going to be for fiber, grain, or cannabinoid production will be evaluated later on.
Hemp is basically composed of two fibers. One is called the bast, and it's on the outside, and it looks like this. It's long and it's stringy, it's strong, and it's used to make clothes, some paper, and a bunch of other kinds of products like rope. The inner stuff is more woody, and it's made of short fibers. It's called the hurd. It's not used for very much right now, and this short, like stuff that has no use, composes about 80% of the fiber in the plant. So what we're trying to do is find more uses for it. So one use is we're trying to breed for longer inner hurd fibers so that we can make more things like paper and higher value products out of it so they don't have to dispose so much of the plant, you know. The other uses we're doing is we're breaking those fibers down even smaller into something called nanocellulose. Let me find a good one. So basically, nanocellulose is so small that it just stays in the suspension, and you can make things like, you can use this as an emulsifier to emulsify fats within water, so it has tons of different cosmetic uses, and it can also be used as like a plastic strengthener. So it can be used in composites and things like that. And it's like 100% natural, 100% plant-based.
I study pesticides, essentially, insects, and formulating a pesticide more specifically from the molecules found in hemp. So I use the terpenes, the oil predominantly, and then we're also using the cellulose that Joshua Van Dyke is formulating to emulsify the pesticide. So we're trying to find something that's organic, that's non-toxic, that's safe for application on things like cannabis, whether it's for field hemp or for indoor cultivation, and also for things like strawberries, microgreens, things like that, food production, things that we can spray on our food and not be worried about, you know, cancer-causing chemicals, nasty emulsifiers, things like that. One of the reasons I came back to school was to help the planet. You know, very, very general, vague goal. I wanted to find some way that I could make things more sustainable, friendlier to our health, just anything to improve our relationship with the planet. And something that I hear a lot about is organic versus inorganic foods and what's really safe to eat, and are the chemicals they're spraying on our food going to cause us health detriments down the line. So the benefits with my pesticide versus, say, other things they use in industry right now are the cellulose emulsification, which is again what Joshua Van Dyke is working on. Instead of emulsifying it with synthetic emulsifiers that they've been shown in preliminary studies to cause different things like decreases in fertility, potentially carcinogenic, like hormone blockers, things like that. So I can emulsify it with cellulose, which is basically the bones of plants. It's what paper is made out of. It's what your shirts are made out of. So it's emulsified with cellulose. The active ingredient isn't a synthetic neonicotinoid or some other compound. It's terpenes. It's what the plants produce to repel bugs naturally. So we can actually extract the natural plant defenses chemically, and we can incorporate that into a pesticide. So we're applying plant-based chemicals to the plants, things that they already produce, and maybe some other plant produces a better chemical, and we can apply it to a wider range of crops than just the one that produces it. So we can use terpenes, we can use the oils of the plants too are common smotherants in organic farming. So it's an entirely plant-based mixture. A lot of the organic pesticides, a lot of people think that organic means no pesticides. It really just means that the pesticides are organic, or that they're on a synthetic exclusion list. And there's actually a substantial list of synthetic exclusions that they allow to go into organic agriculture. So this would be a truly organic, plant-based product.